So here we have a piecewise function. All a piecewise function is two different graphs that you know how to graph, and you just have to graph a small piece of each one of them. So here it looks complicated, but what we have, and I'll label it here, I'm going to do 2x plus 1. Is that a graph that's hard to graph? No, it's just a straight line. And x squared, that's my second equation. That's not a hard graph to graph. It's just a parabola. When graphing piecewise functions, sometimes what I like to do to start with is to graph them in their entirety to begin with a dotted line. I'm just going to graph in green 2x plus 1. Well, that has a y-intercept of 1, a slope of 2, so I'll go up 2 over 1, up 2 over 1. And with a dotted line here, that's what 2x plus 1 would look like. In blue, I'm going to graph x squared. Well, that's a parabola at 0, 0, over 1, up 1, over 1, up 3, something like that. And I'll draw that one as a dotted line as well. So there's both graphs graphed at the same time. The reason we can't graph both of them together is it wouldn't be a function. Remember, a function passes a vertical line test. If I drew both the blue and the green simultaneously, there'd be lots of places, in fact everywhere, where it wouldn't pass the vertical line test except for where they intersect. So very few places that would still be a function. But what the piecewise function always has is a domain attached to each function. So we're going to graph 2x plus 1 only when x is bigger than or equal to 1. Well, here's 1 on my x-axis. And on my green graph, when I plug in 1, 2x plus 1 is 1 comma 3. So on my green graph, I'm going to label that point 1 comma 3. I'm going to label it with a solid dot because we had this equal sign there. On my blue graph, when I plug in 1, I get 1 comma 1. I'm going to label that one with an open circle because there's no equal sign with the x squared graph. And now I'm going to draw my final graph. I need to choose the green graph when x is bigger than 1. So that's going to be this part of the green graph, including that solid point. And I need to include the blue graph when x is less than 1. So that's going to be here's 1, and I need to include everything on the blue graph when x is less than 1. And my final graph there still passes the vertical line test and is a function, and it has two pieces. That's why it's called a piecewise function, because it comes in more than one piece. And we just graph the piece that we're asked to graph. When you get really good at these, you don't have to draw the whole thing. You could just draw the piece that you needed. But sometimes it's nice to draw the whole thing first to get a visual of what's happening, and then with a solid line fill in what you need.